So my name is Rob Neff. I am coming from Flex, which is and I'm going to discuss our Flex community cloud labs and how we've been working with different open source networking projects and how we are planning on using our new Open19 hardware platform with the Akraino project that will be coming in spring of 2019. So the first thing I want to talk about is who is Flex? Flex is a very large manufacturing and design center with our headquarters here in San Jose and a large design campus in Milpitas. We have about 10 locations around the world, and we deal in a lot of spaces, whether it's medical, automotive. We do design and manufacturing, but the area that I work in is our Cloud and Communications Solutions group. And that involves designing 5G wireless telecom devices, designing switches, designing servers, or storage appliances that are then often rebranded by local Silicon Valley giants and startups. So Flex decided about a year ago that we would make an investment in a lab as a service. As we talked to large telco operators, they often expressed that they just didn't have enough lab space, as big as they were, to run different trials. And we found that it was a great way to engage them was to have a lab with equipment they were interested in, and then deploy open source projects, run benchmarks, test them, and collaborate on how we can improve either network performance or VNF performance or full OpenStack performance. So this lab has can be divided up into different pods for different customers, so everybody has a secure VLAN and a dedicated connection to the internet. It's very easy to access. You just go to flexcloudlabs.com if you're a partner or you're in the OPNFV community or the Cord community or soon to be the Akraino community. You'll be able to log in and get a pod and deploy a workload there. And the reason why we do this is to promote open hardware platforms. We're an OCP member, we're an Open19 member, and we also work with other platform vendors. So we want to make sure that software stacks work with our hardware. And we want to promote the very popular consortiums such as OPNFV, ONF, and OpenStack. Finally, we've developed an automation framework so we can do performance benchmarking from a very low level all the way up the stack. And I'll talk about that framework here. So this framework we call Automata, and we use it for a lot of different hardware systems that we test. So we can test drive performance. We'll work with companies like Intel or Micron on benchmarking their NVMe drives to SNIA standards. We'll work with our IoT design center to test Raspberry Pi devices. We have an automotive group that designs servers for self-driving cars, and we'll test those. And we'll even test full racks and deploy different solution stacks on top of that. The current supported OSs that we work with are like CentOS, Ubuntu. We'll deploy stacks such as Kubernetes or Red Hat, OpenStack, and Ceph. We do all kinds of testing around the CPU with Spec or Unix Bench. We do memory testing, drive testing, a lot of FIO testing, network, GPU, stress test, and then all kinds of infrastructure and cloud application tests. So if you have a MongoDB cluster, then we can test that. And we monitor the system with different telemetry solutions, such as Telegraph, and then we collect the logs with beats. And we visualize all of these, we store all the results in a Postgres database, and we store the logs in an ELK stack, and then the telemetry, we store that in a time series database, which is InfluxDB. And we graph the system response, whether it's fan speed, CPU usage, memory usage, disk ops. So this allows us to do a lot of different things: inventory of servers, diagnostics, log analysis, benchmarking, stress testing, doing different workflows, whether it's stressing the system, rebooting it, then running a drive test. And then we can do synchronous testing across the network where we might spin up 200 VMs or containers and map it to remote block devices, and then check both the network bandwidth and then the overall throughput from the remote block devices to the containers and take the aggregate measurements. And then we'll do multi-rack testing. So we'll test uplink tests across multiple racks. And just a couple examples. This would be how Metabase visualizes a Broadwell single socket solution versus a Broadwell dual socket solution. And then we'll change up things such as turning off hyperthreading or reducing the RAM and seeing how that affects performance. And then we do data sheet comparisons for networking cards, for storage drives, for backplanes, and such. So this gives us the ability to do a lot of testing. And like when we do OPNFV testing with Yardstick, a lot of these tests come into play. So what about Akraino? So I had hoped when we signed up for this presentation a long time ago that we'd have Akraino deployed, but if you go to the website, the code won't be available till spring 2019. But I just want to talk a little bit about what it is and why it's important to us. So all of our customers are members of this project, which has been accepted by the Linux Foundation. Its primary leaders are AT&T and Intel. And the goal is to take a lot of the benefits of the core cloud data center in terms of the orchestration capabilities and move them to the edge. So developing a kind of single pane of glass for high availability, fault management, performance management for cloud stacks that are with features oriented towards the edge, low latency, and security. So if you look at the Akraino goals and the scope, it's to have an edge solution for the telco, enterprise, and industrial IoT use cases, to have an edge API that can be programmed against for a bunch of different edge applications, and to be able to develop edge middleware, and finally, to be able to create blueprints for pods. So this is a point of delivery, and this is a blueprint is basically a reference architecture, and I'll show you a few reference architectures in the next slide. And then, I think the key feature is this single pane of glass control. That's what everybody who manages 10,000 edge sites, they want to have a single pane of glass to manage all their different sites, and that's not how it's done right now. So if you look at the Akraino design principles on their very nice wiki page, they use Confluence like us. They want to have a finite set of configurations, so that finite set of pods, you might say. They want to support cloud-native applications, so basically containers and microservices. And they want it to be a autonomous turnkey solution. So the key is they don't want it to be like OpenStack, where it was very hard to get it all set up. The goal here is to have something that anybody can turn on like an appliance in the edge. And as you know, the only reason for doing, or one of the main reasons for having an edge solution is low latency. So the key here is to make sure that there's driver support for low latency networking. And then, again, I think the single pane of glass talks about, speaks to the zero-touch provisioning and the life cycle and managing it through APIs and improving ONAP for the edge. This is an example of 5 different Akraino pods or blueprints, and they have different use cases. So you have the cruiser, the large pod on the left, and the tricycle medium pod, which are for the kind of telco hosted edge. And these would have components such as ONAP or OpenStack, and it would be deployed via airship. Then as you move down to the Unicycle pod, the satellite, and the rover, you're getting more towards the remote edge side of things. So these are where you have thousands of edge locations with disaggregated hardware, and if you deploy Akraino, it's supposed to make it much easier to manage these very remote sites. And some applications are like OTT, over-the-top voice, and Internet of Things gateways. The Akraino Edge Stack has a number of pieces. I mentioned the UI and the workflows that are being developed. I think the key pieces that AT&T and Intel have specified that need to be improved are ONF, and then the orchestration to bring together Kubernetes and OpenStack. And for the hardware piece, we're offering up our Open19 hardware platform. So Open19 hardware is designed for the edge. It was developed by LinkedIn about 2 years ago and announced in May of 2016. And the goal was to develop more for an edge data center where you have a lot of, you can often have a lot of changes happening, and you often need to build up hardware quickly. You don't have a lot of time to spend days cabling different servers together. You kind of want to be able to take a specific use case server and just plug it into the rack and have it just boot up and be provisioned and ready to go. And also, in these edge locations, you don't have a lot of power. So Open19 is a very power efficient, kind of a low power rack solution. So we look at this is an example of an Open19 rack. In Open19, we call the different servers bricks. So you can have a brick is kind of a half-width server by itself, and then you can have a full-width or double-wide brick, or you can have what would be called like a 2U brick, which is a double-high brick. You can even have a 2U half-width brick. So there's a lot of different form factors, and these little, in these cages here, which I'll show you on the next slide, you can remove the different pieces so that you can fit different size bricks in. So the nice thing is that every brick has 50 to 100 gigabits per second of networking immediately. As soon as you plug it in, it snaps into the back, and you have very high speed, low latency network speed. All of the server bricks that we make have at least 2 NVMe drives. Some of them have up to 8, and that's in a half-width 1U brick. And then the key here is, it's a standard form factor, so the outside of every brick is going to be the same. They're going to have the same power connectors, same network connectors, fit into one of these form factors, but the vendors keep their unique IP, unlike OCP, where you kind of have to give away your IP when you contribute. These are the building blocks for Open19. So you have the cage, which can come in 12U or 8U form factors, and supporting 16 and 24 bricks, respectively. You have these snap-on power cables on the backside that provide anywhere from 250 to 400 watts per brick, and then the snap-on data cable. So you snap all of this together, and I'm going to back up for a second, because that's one of the key things is the 5x gain in speed of full rack integration. So there's a video on the Open19 org where two guys who don't know anything about Open19 install it into a standard 19-inch rack, and they do it in about an hour and 15 minutes, which is kind of unheard of for putting full rack together. And this was actually a 52U rack, so it had 4 12U cages in it. So going back to the components, I mentioned the cages, and then there's a network switch that has 3.2 terabits of switching capability, and it can handle all 48 server bricks if you're using those smaller half-width 1U bricks. And then a power shelf for all of those 48 bricks. And then on the right, there's bricks which we have Skylake E5 CPUs, and they can have up to 100 gigabits per second per brick. And a brick can take up to 400 watts under if it's under load. So when we put all those components together, then what we can do is offer this as part of a Unicycle pod setup. So if you go look back, I'll back up to the Unicycle pod, which is this middle one here. This is the one rack pod with a containerized control plane. and Kubernetes-based resiliency for IoT workloads. So this is the first pod that we're going to have this spring running Akraino. And we'll have this in our lab as a service, a cloud lab. And any community member of Akraino that wants to try it out or do a test deployment can do that. We often, for OPNFV and Cord, we always connect to the official Jenkins server. So we have the opportunity to just launch the latest build and run tests against it so that whoever's using it can know if it's a stable deployment before they start their own testing. So we're taking the Open19 design to the edge, and we're making it available to the Akraino community in spring 2019 as soon as the release is made available. We see this in terms of our flex value to the customer as our hardware systems integration and interoperability growth. And we'll have these bricks, Skylake bricks available, the switch, and everything set up as I've shown you. So this will be available, and thank you very much for your time.
Questions? So I have one. Akraino blueprints, we're working with Akraino to get SIBA accepted as a blueprint, except SIBA will need some OLT hardware. How would that work in the Open19 setting?
I believe that, Sid, you might be able to help out with that one.
As mentioned, this is if you see one cage that would contain like 16 servers max, right? But let's say if you have an entire rack, you can add additional OLT boxes just beneath the boxes, and then you can connect it. That's how it would be. So here the whole important point of the server bricks was it comes with different form factors. So you can have like half width, full width, and all of these, and then it could easily go with other components or the access devices such as OLT or for MCOD or anything. So.
Thanks. Any other questions?
Okay.
All right, thank you.